Thank you, Jill. Hello, everyone, and welcome to my kitchen, which is located about 30 miles away from Bentley Motors Limited, where we manufacture, here in the United Kingdom, luxury vehicles in a town called Crewe. Bentley have been handcrafting luxury vehicles for over 100 years, so you're probably wondering why Bentley Motors are working with Intel, and I'm talking to you today. Well, as virtual media manager for Bentley, I am responsible for the rendering of the images used in our car configurator. Now, you're probably aware that all automotive companies have car configurators to help the customer select the perfect vehicle. What's the interesting challenge I have as the Bentley Virtual Media Manager? Well, our vehicles are the most configurable in the industry. Our simplest cars have over 10 billion orderable combinations that our customers can select from. So when we launch a new vehicle, such as the new Bentley SUV shown in this image here, we have about 16 weeks to render all the images required for the car configurator. Now, obviously, even with Intel technology, we're not able to render over 10 billion images in 16 weeks. What we actually do is we use ray tracing and we render images of every single part the customer can see on the car in all its available colour options. This means instead of rendering over 10 billion images, we only need to render about 280,000 images for a new Bentayga. Our entire fleet of vehicles require about 1.7 million images to cover all the derivatives and models we offer. And these images need to be maintained in line with product changes, ongoing customer enhancements that we do to our vehicles throughout their life cycles. So to give you a little bit more of an in-depth view of how we render these images, this is a slowed down video showing how the visible parts are composited in our configurator as the customer goes about configuring their perfect Bentley. Now, as this video plays, you can see the configurations come in and the vehicle's changing. Now, what not a lot of people know is that these rendered images are actually metadata tagged using the same system as the data tag and check our physical vehicles are correctly built on our production lines here in Crewe. What this means is when you're actually using our online configurator, you're actually building digital vehicles in our factory in Crewe, which I think is pretty cool. So why do we use the same systems as our factory? Well, it's the most efficient way of ensuring the digital and the physical car are aligned. And really, efficiency is why I'm here talking to you today, as my job is really to unite luxury and technology in the most efficient way to help our customers commission their luxury Bentley. As I look to the future, it's clear I'm subject to the same exit trends in rendering and requirements for 1000x increases in productivity, as Jim has already mentioned. For example, I am also looking at data explosions. By 2022, my digital fleet will require over 2.5 million images to be maintained each year. So we need scalable rendering solutions to be able to meet this demand. I'm also challenged by interactivity and real time because we build dynamic emotional luxury products. So our sales tools need to support this for product experiences in dealership and at home, or however and wherever our customer comes in contact with our business. So we need globally accessible, scalable, delivery solutions. I say scalable delivery solutions because car configurator visitor traffic can vary from tens of thousands on a typical day to tens of millions when we launch a new vehicle. So we need to be able to cope with big changes in volumes of traffic, especially if we start looking at real-time and interactive experiences online. We also are looking to increase or have higher fidelity in our images. Now, a lot of people talk to me about photorealistic. Photorealistic is good for emotional hero images. What we actually require for a car configurator sales tool is hyper-real images. Now, what do I mean by this? So in this example, you can see online, we have two images of the same vehicle. On the left-hand side, we have a photorealistic hero image. And as you can see, the car is picking up colour and reflections from the environment. Now, when you're configuring a car, you're actually looking at the materials, the colours, the textures of the vehicle and how they come together to build your perfect vehicle. So if I was to go to photorealistic, I wouldn't be quite sure if that was a polished or painted wheel because it's picking up some ground reflections. Also under the door handles, you can see the style line is being highlighted in quite a light tone. So this could be interpreted as a chrome strip. So this is why we need hyperreal rendering. This is where the rendering allows the customer to see the material clearly and see the definition of the shape. So we can clearly pick out the wheels are polished, the chromes are chrome. Now, if that was a completely real image in a studio, the chromes would be picking up the ground and the ceiling, and it'd make the chromes look dark. Now, this is important because some of our options, as we go on to the next slide here, you can see the same car fitted here with a styling pack, which has dark chromes. So we need to have clear definition of what the materials are. And this is why we have hyperreal images. On the image on the right here, you can see the interior. It's very important that the interiors are color graded across all the leathers. So we offer a huge range of interior colors. So we can have up to 25 different colors on our vehicles interiors in different areas where the customer can select where the colors are placed. So it's important that the color looks consistent and the customer knows which combination of colors are going where. Also, when you're selecting things like the veneers you can see here, if I was to have photorealistic images, I wouldn't be able to see the veneer because it would be reflecting on the interior. So we have to be able to control the reflections and the shadows in our renders to be able to see the material you're actually picking, not the photorealistic environment. So this is where we need high fidelity control of our rendering to create these hyperreal images. We're also, with the introduction of AI into rendering, it enables faster rendering, but that also requires us to check media faster. So we're now looking at integrating AI checking of our digital craftsmanship into our render pipeline. We call this no pixel left unchecked. This helps us to get more right first time, reduce the number of iterations to achieve hyperreal images, reduce and optimize the capacity of our render farms, which is very important as we look to the future on our requirements to render more images, but we need to do this in a sustainable manner. So we do want to have overcapacity in our render farms. The other big challenge we have is supply and software integration. I work with many fantastic suppliers and use a lot of great software in our car configurator pipeline. Unfortunately, this often leads to compromises, such as reducing the number of triangles in our 3D models, signing off and maintaining different material libraries for different software platforms, rendering engines, and media viewing platforms. It can also result in Bentley having to change the ways of working to meet the third-party software requirements. None of this is good for cost-effective, efficient creation of rendered images. Every time we deviate away from our desired way of working, we end up incurring costs and have to check additional things. By working with Intel on the oneAPI rendering toolkit, we've been able to leverage and take advantage of its open source platforms. This has meant we've been able to rapidly research and develop proof of concepts that focus on cost-efficient methods for the creation of rendered images and user experiences for the future that have less impact on Bentley ways of working, also use authentic 3D data used to manufacture our vehicles with no additional effort or cost to reduce the number of triangles in the 3D models. We've been able to develop real-time collaborative processes to achieve hyperrealism faster, and we're investigating single solutions that are scalable from the user's desktop all the way through to cloud data centers that can be globally deployed to our users and customers. We've also been able to leverage Intel's AI toolkits in the checking of our digital craftsmanship within the rendering pipeline, And obviously research and development is still ongoing, but what I would like to show you now is some of the first outputs that we would like to share with you of a video that shows a full CGI dealership with a large number of fully configurable cars that many users are able to interact with using the OSPRay Studio platform. I hope you enjoy and thank you for listening. Thank you. Goodbye.